we are all welcome once again to today's class. So, what we'll be doing today will be a build up on what we've done the other day. So, I will continue from where we stopped in our last class. So, I'll just do a little refresh of what we did, but I'm not going to dwell much on that. If you need further details on that, you can refer to the video which I did for last class. I believe my screen is clear and visible, right? And my voice is audible too. So I should know I'm not talking
Yes, yes, it's
nonsense.
clear. Can hear you.
All right. Okay. So let's proceed. So in our last class, I introduced the concept of data analysis. I mentioned some libraries. I said that we usually use some libraries to perform calculation. We use some for visualization, and then we use some for machine learning model development. And from what we did in our last class, we started doing some data manipulation where I gave you a data set, we cleaned the data, we we cleaned the data in the sense that we drop some columns that are not relevant, missing values that are in the data set. I taught you how to fill them, and then I also taught you how to remove them where the case may be. So that day we wanted continue from future engineering, then we stopped. So today we'll proceed from feature engineering. I taught us how to perform exploration. I said we have two types of exploration. We have statistical exploration and we have visualization. So today, last class we did the statistical exploration. Today we'll be looking at other pre-processing, and then we'll also look at the various type of visualizations that we have. So, without much wasting of time, let's commence. Now, if you remember in the last class, I was talking about feature engineering before we stopped. I said feature engineering. Now, machine learning or in data science generally, remember I told us that each of these names stands for the columns that are in your data set. And then I said each of them, we call them columns. Now, in machine learning, another name for column is called feature. Another name for column is called feature. If you hear me mention feature, you should know I'm making reference to the columns. So now this data set, I can say this data set has three features. Now, feature engineering is a method of engineering whereby you combine two or more features to create a new feature. That's what we call feature engineering. Feature engineering has to do with combining some feature to get another feature. For instance, let me show you a practical example is velocity in physics. Now, for those of us that did physics, I think velocity is equal to speed divided by time. That is the formula for velocity. Now, ideally, now if I can give you a data set that has just speed and time only as the columns. Now, data speed divided by times and time square. I think that's the formula. Yeah, speed divided by time square. That's the formula. So so if I should give you a data set that has only speed and time, from speed and time, you will be able to create a new feature called velocity by dividing the speed divided by time. Now that is what we call feature engineering. So please take note, feature engineering has to do with you creating a new feature from feature that is already in your data set. Now, you as a data scientist, feature engineering is up to you. You are the one that will know the combination that you want to do to create a new feature. But make sure those features you are combining are relevant. Don't just feel like because I say you can combine feature, then you say, okay, you want to do feature engineering, you will now combine height and gender. No, that's not how feature engineering works. Make sure those features that you're trying to combine, make sure they produce a meaningful feature. So that is what feature engineering is all about. But mind you, I say feature engineering has to do with combining two or more. So it can be only two features, you combine them to get another feature, or it can be more than two. You can combine three, you can combine four, like that, to get a new feature. So that's what feature engineering is all about. So back to our data set. Now I skipped all these things up here because these were things we did last on Friday in our last class. So that's why I skipped them. So I'll continue from here where I check this info. Now, if you check this data set, our data set has features: height, sex number, and then shoe size. These are the three features that we have. Now, me as the programmer, I want to create a new feature using these existing features. Now, to create that, I said the name of my feature should be size per height. That's like the average shoe size of people that are belonging to a. It's just like I'm trying to take the ratio of the height. If I say ratio, it means I'm trying to divide height by shoe size. I want to get like the median. That's like the average range. Though not actually shoe size range, but I'm just trying to form a new feature that will be able to like measure the scale of how shoe size is supposed to be. That is what I'm trying to do. So to do that, I said my size per height should be height divided by shoe size. That's the formula that I have in mind. So in order for me to apply this formula to create my feature in my data set, remember we said data sets are like dictionary. So any feature that you want to access, you just write data. Remember, we call our data. So you just write data dot, then the name of the feature. Like if I want to access all the height, if I write data dot height, I can have access to all the height. You get. So now I want to create a new feature called size per height. So in order for me to create that, remember it's not in the data set. So I need to create it. So in order for you, and I said whenever you are trying to create something, remember when we were doing dictionary, if you are trying to create something, you will write the name of the dictionary, quotation mark, then the name of the key. So the same thing applies in feature engineering. You need to assign it to a variable. So you write the name of the data set you want to add it to. You write the key of that new feature you are trying to create. So this is the key. Then followed by your equal to here. Now this is where you will now write this formula that we wrote up here. This height divided by shoe size. But remember, height is not standing on its own. Height belongs to a data set. So you must make reference to the data set. So how will I do that? I will say data dot height. Exactly the way I wrote it formally. Data dot height is what gives me access to my height. Then followed by my divide. I said my size per height should be height divided by shoe size. So I've gotten access to my height. Now I'm going to my shoe size, but so I need to put the division sign first before I say data dot shoe size, and then I run it. The moment I run it, a new feature has been created. So how will I check now that feature? The moment I run my data, you see that that feature will be included in my data set. Now you can see my data set now has a new feature created. So that is what we call feature engineering. So please take note. Feature engineering has to do with you creating new features from features that are already existing in your data set. So that is what feature engineering is all about. Okay. Now, what I did here and what I did here are the same. The difference is that here I use data.height to access my height, data.shoe to access my shoe. Whereas here, remember that day I told you another way if I want to access the entire height, or maybe I can do it like this. Same way we do it in dictionary is the same thing. So that was what I did. Just that here I use dot, here I used it in form of a dictionary. So they are the same. Either you do this one or you do this one, anyone, it doesn't matter. It's still going to give you the same result. So That is how you create a new feature. So our data set now has a new feature. Now, I want to use this new feature again to create another feature. I want to use this new feature to create another feature. And the name of that feature I want to create is good bad size. Good bad size. That's the name of the feature I want to create. Now, what is the feature? What I want that feature to do is I want it to I'm just trying to create a feature. It's not that it's applicable to shoe size. I was just trying to show you how feature engineering works. So the condition for me creating that feature is I want to check this shoe per height. I want to check what is the average. Average means what is the sum, then you divide, you want to get like the average. It's just like say average age of people in a group. Like maybe they're expected to have an average year of 25 years, something like that. So I want to get the average of this shoe per height. And then from there, any shoe per height size that is greater than the average, it is a good shoe size. Then any shoe per height that is lesser than the shoe that is lesser than the average or is from the average downwards is bad. So that's the condition I want to do. So in order for me to do that, I want to find the average of this column, this size per height. How do you find the average? If you want to find the average of any column in a data set, all you do is you write the name of the data set, followed by the column name, size per height. Or if you like, you can do it the other way around like this, size per height. And then after doing that, you write dot mean. Dot mean is going to give you the average value. So this average value that we are seeing here in this bracket, or to remove this np dot float, let us put print. Now this is the average shoe size, 4.20. That is the average shoe size. And then let's say you want to check the highest value. Now if you are trying to check the highest value, that's like the highest size per height, or maybe shoe size or height or gender, anything, as long as you want to check the highest value. If you are trying to check the highest value, that's the maximum value, we usually use the keyword max. So whenever you want to check the highest value of something, you use max. Then whenever you want to check the minimum, that's the smallest value, you use min. So you can see. So in this my size per height, this is the highest size per height we have, 4.77. And this is the lowest size per height, but the average is 4.20. So I want to use this average now to check, to create another column called good bad size. So how will I do that? First of all, what I did was I created a variable called size per height. Now what this variable does is I want you to hold all the values that are in this size per height column. I want you to hold all the value. So that is what I did here. This size per height equal to data size per height. I want you to hold all these values because in order for me to check, I said the condition for a person to have a good shoe size is his shoe size per height must be greater than the average. My average is 4.20. So let's use normal using our eyes to do the analysis. Now, if you check here 4.20, 4 is not up to this 4.000, is lesser than 4.20. So if we are creating a new column called good bad size, this very first person will have bad size because his score is lesser than the average. This person will have good size because the score is higher than 4.20. This person will have good, this person will have good, this person will have good. There are others. This person here will have bad because his shoe size is lower. This person will have bad, this person will have good, this person will have bad, this person will have bad also. So that is how you check. So in order for us to do that, we have to be comparing them one after the other, the way I'm saying it. But it will take us time. So in order for us to reduce work for ourselves and to allow our machine do the work, we will create all these variables that are in this column, we will give them to a variable so that anytime we want to make reference to them, we just call the name of the variable. So I gave it a variable called size per height. I said size per height should be equal to data show per height. That is, it should have all the columns, all the values that are in this column. So that is what I did here. So let's run it. And then after running it, let's print it and see. Size per height. You see that it has all the columns that are in that data set, that are in that column. It has all the values that are in that column. Sorry. So you can see all these values here. You can see they are the ones here. Now, why do I create that? I create that because I want to do a condition here that will be able to check whether the shoe size is good or the shoe size is bad. So my main is 2.0. Sorry, I think I did a mistake here. All right. So now, how will I write the condition? Now, please pay attention very well here because it's a little bit tricky. Now, numpy. Remember, I taught us that day, I said if you want to use numpy, you say numpy, import numpy as np. And then I told you something. I said we use numpy for manipulation of data also. So numpy has a function called where that allows you to check condition. The same way we are using if statement. The same way we are using if statement, you give it a condition. NumPy has a function called where that allows you to do some manipulation. So how do you use that where? All you do, you say np dot where. Then you give it the condition. Now, what is our condition? We said in our data set, we want to check this size height that we created here. This size per height that we created, we said we want it to check each of the value. Anywhere it sees a value that is greater than our mean value. What is our mean value? When we printed the mean is 4.2026. But me, I just put 4.20. So this is the mean value. So we said whenever we have a size per height that is greater than the mean value, comma, if the condition is met, that is true, that shoe height is greater than, the good bad size should be good. But if it is not greater than, the good bad size should be bad. Now, after, what where does is where allows you to pass three parameters. Remember, anything that is inside bracket, I told us is parameter. The first parameter is your condition. The second parameter is what should be printed if the condition is true. And then the last parameter is what should be printed if the condition is false. So if the shoe per height is greater than 4.20, good will be outputted. But if the shoe per height is lesser than, is equal to 4.20, bad will be printed. Why? Because bad is the condition for false, whereas good is the condition for true. That is, if the shoe size is greater than this 4.20. But remember, we passed it to a variable called good bad size. Why do I pass it here? Because at the end of the day, I want to create it and give it and include it in the data set. Or directly, I can just do it direct here. Instead of me to go out and be doing it afresh, I'll just write. Remember, we said whenever you call a data set and then you pass a name, you are doing feature engineering and you want that feature to appear in your data set. So I'll just give the name good bad size like this. Good bad size. So there's no need for, let me delete this. So a good bad size column, we said we want to use numpy and check for a condition where our size per height is greater than 4.20, we should print that the shoe size is good. But if the condition is not met, we should print that the shoe size is bad. So let's run it. After running it now, we have created a new feature. Now, mind you, and whenever a feature is not in the data set and then you pass it like this, it will automatically be created. But if the feature already is in your data set and then you create it again, it will go and replace the old one that is in the data set. You see that the old one will change. So that is how it works. If a new one is being created, it will be added. But if an old one is there and you create it again, it will go and delete the old one and then replace it. So let's run our data set. Now you see that our data set, now you see another column has been created, whereas this one has good, bad, like that, like that, like that. So our data set from P, we have done feature engineering, we've created two more features in our data set. That is how feature engineering works. So I now calculated, okay, this good bad size column, all these things are things I thought of that day. I said you can now check how many good are in the data set, how many bad. How will you do it? You will say data, the name of the column, and then you say dot values. Or you can say data dot good bad size dot value count. And then we run it. Now you can see this is the statistics. We have 95 good size and we have 59 bad size. Now that brings us to two more concepts I want us to talk about. Now the first concept is okay. The second one, before we do that, maybe after we done visualization, we're going to talk about that. Okay, the first one is that day I there was something I mentioned in our last class. I said in machine learning does not understand letters, it only understands numbers. Now, if you check, all these are numbers, these heights, they are numbers, genders are numbers, shoe size are numbers, size per height are numbers. So machine learning model don't have problem with this one, two, three, four. But this good bad size is not a number, it's a collection of letters. So if we are to use this data set now to build a machine learning model, we will encounter an error. Why? Because we have a column that is not a number. So, but if you look at good, bad, good, bad, good, bad, this is a categorical data, which I believe I explained that I told you categorical data are data that you can group some things. So, this good, bad size is a categorical data. It's not just a string. It's not an object. It's a categorical data. So, since it's a categorical data, I told us that I said categorical data, you have to convert them to numbers. So, that's what we'll be doing next. How can you convert categorical data to numbers? Now, in order for you to do that, there is a library called Label Encoder. Label Encoder is a library that helps you to transform something from one form to another. It allows you to transform numbers or categorical data from letters to numbers. That is how it works. And it does its classification based on alphabetic order. Like now in alphabet, letter B comes before G. B for bad, G for good. So if it's going to classify, it's going to classify bad as 1, then good as 2. Why? Because bad comes first before good. So, but ideally it starts from 0. It starts from 0. So bad will be classified as 0. Remember I told you anything that has to do with indexing starts from 0. So it also use that concept. It always starts, in fact, program generally, it starts counting from 0. It doesn't start from 1. It always starts it counting from 0. The only counting that starts from 1 is when you are trying to check the length of something or the numbers of something. That is when it starts its counting from 0. Aside that, any other thing, it starts it from number. It started from number 0. So please take note of that. So, all right. So back to what we are saying. I said we use a library called Label Encoder, and I said the Label Encoder works by first of all converting the alphabet that comes first and gives it 0. The ones that come next, it gives it 1. If there's another one, that letter that comes next after G, maybe let's assume we have good, bad, and then maybe we have I am not sure, something like that. I comes after G. So that I am not sure that I said it will be classified as number 3 because it will be classified as number 2, sorry, because it's letter I comes after G. So that is how the label encoder works. So how do you use label encoder? First of all, you need to import it. Remember, we said everything in Python, especially if you are working with machine learning, has to do with importation. You import very, very well. So how do you import? Now that day I made mention of a library called sklearn. sklearn or scikit-learn, I say it's a library that we use for machine learning model development. So this label encoder is inside that sklearn. So if you want to access label encoder, you need to import it from a library called sklearn.preprocessing. I will repeat. For you to use label encoder, you need to import it from a library called sklearn.preprocessing. So how do you do that? You will start, unlike the other one, we are saying import numpy, import pandas. We are doing it like that because we are not importing them from a place. They are on their own. But this guy, this label encoder is not on its own. It's inside somewhere. However, you can do it the same way we've been doing before. You can say import sklearn.preprocessing first, and then whenever you want to work with the sklearn with the label encoder, you can say sklearn.preprocessing then dot label encoder. It will still work. You see, I imported my sklearn.preprocessing normal. Or I can say import sklearn.preprocessing as sp, for instance. So here I'll just say sp.label encoder. Same way we did when we are doing all these data.info, pd.csv, numpy.mp.where. It's the same thing. So you can do it like that. However, for good practice, do it this way. Whenever you just need to pick something from inside the library, it's not the whole of the library you want. Just you can just go and pick that thing. For instance, now let's say I want to just use only read CSV inside my pandas. So instead of me to say import pandas as PD, and then I started saying pd.read CSV, and then I pass the name of my data. Another format that you can do, you can just say from pandas import read CSV, and then you use it. So this one allows you to have access to only that read CSV that you want to use. It's not going to import the whole pandas for you. So, but if you say import pandas, it's going to import the whole pandas, even other libraries that you are not functions that you are not going to use them. It will include them. It's going to include them in the work you are doing. But if you want just a specific uh, page or a specific function, remember that day I told us the page is whenever I'm making reference to a page in a library, it's as if I'm making reference to a function. The pages are like function. For instance, read CSV, info, shape, CORR for correlation that we did in our previous class. So if you want to make reference to just that, you can just pick only that. So I want to use only label encoder. So since I want to use only label encoder, I'll go to this sklearn.preprocessing library and then I'll import only label encoder. So after importing it, how do you use it? In order for you to use label encoder, you must create a variable that will hold the label encoder for you. So you can call it any name. Me, I call it Ellie. But mind you, the name you use to hold it will be the name you will use when you want to reference it. So I created a library called LE and then I pass this label encoder here. I pass it to that library. Remember, it's a function. So since it's a function, it must have open and close. I told you any function. Please don't forget that. Any function, as long as it is a function, it must have open and close. I told you the only function that doesn't have open and close is only shape. If you are checking shape of your data, when you do data, when you do data, what's wrong? Data dot shape. That's the only function that doesn't have open and close. But aside that, any other function, info, correlation, whatever, all of them, they have open and close. So for you to use label encoder, you must first of all create it and pass it to a variable. That's step one. Now, step two, you will apply it to that column that you want to apply. You want to convert it to numerical values. So how do you do that? You call the name of the column. What is the name of our column? Good, bad, size. This is the person we want to convert. It has bad, good, good, bad, bad, bad. We want to convert all these good, bad to numbers. So you need to pass that column that you want to apply it. So you will reference it in your data set. So we say in our data set, this data set, which is called data, on this column, good bad size, we want to apply label encoder. So how do you apply label encoder? To apply label encoder, you will call your label encoder, which will represent it as LE. So anytime I want to call label encoder, I'll just write LE. It knows we are making reference to label encoder. Now, immediately after putting that, you will put dot fit transform. This is very important. This fit transform is what converts it. If you didn't put this dot fit transform, the label encoder will not implement. So fit transform means apply it on this column. No, this fit transform, I said it means apply it on this column. So after doing your fit transform, this fit transform is also a function. Immediately you write the le.fit transform, you now write the column you want to apply it to. And what is the name of the column? The name of the column is this column that we wrote out here. So just copy this thing that you wrote here, come back into your brackets and then paste it. That's all, and then you run. Okay, I've not run this place. Okay, so let's run it. Immediately you run it, it has been applied on the dataset. So let's run our dataset now. You see that there's a change. You can see formerly here we're having good, bad, good, bad, good, bad. You can see now we are no longer having good, bad, good, bad. We're having 0, 1, 1, 1, 1. And remember, look at, I told you letter B will be giving 0, G will be giving 1. So you can see we have 0. And mind you, we have only two unique values, good and bad, in this column because we checked it. We did a value count for it. Or you can check, you can use the unique, you can use unique keywords to check it. Good, bad, size, dot unique. Already, though we have converted the data, so you see it show only 0 and 1 because we have already converted here. So this is how you apply label encoder. So whenever I tell you change a particular categorical data in a data that I give you, I said change it to numeric. This is how you apply it. First step, import label encoder from sklearn.preprocessing. That's step 1. Step 2, pass the label encoder to a variable, maybe LE, LB, or anything of your choice. But mind you, I said the name you use here must be the name you put here. So what will be outside? What will be outside here is that column that you want to apply label encoder on it. So the name of the column is good bad size and it belongs to our data set. That is this data that we have been talking about here. So that is why you write the name of the data set and the name of the column. And then you say equal to, how do you use the label encoder? That variable name that you give it here, write it. And then you say dot fit transform. Because fit transform, it was help it to convert. Then inside the bracket, what will you write? You will write that column that you want to apply it on. So I said simple way is just for you to copy the name of the column that you wrote out here and then paste it. So that's to say whatever is outside here must be the same with what is inside here, and then you run. So the moment you run, that's all. You've applied your label encoder. So you can now output your data. You can maybe do data.head or data.tail. Anything you do, you run, you see it output with those columns changed. So that is how label encoder is implemented. Okay, someone's hand is up, so you can ask. You can ask your question, sir.
Okay, good day everyone.
All right.
Please, my abeg, my question is, but sorry, like the beginning of the class, I wasn't really paying because I was actually on the road, so I didn't really understand the beginning of the class. So I
Okay.
want to understand this good bad side is it, like, did you add it to the
Yes, we
like?
created it.
Okay, okay, okay,
Yes, we did label. We did feature engineering. I said feature engineering has to do with creating new columns. So we did feature engineering, whereby I said we are trying to check the size per height. If the size per height is greater than 4 point, if the size per height is greater than 4.20, we'll say it is a good true size. But if it is less than, we'll say it is a bad true size. So that was
okay,
how we created that good true size. So this was where we created it. Look at where we created it. We used NumPy and then we gave it a condition and then we created it. So that was how we created it.
Okay. All right.
All right.
Yeah.
So any question on any other person with another question specifically on this label
Yeah.
encoding?
Sorry, please. I have another question. Sorry.
Okay.
Um, I was hearing you saying something like when B equal to 0, then G equal to 1. I want like, do you mean
Yes,
bad? Like,
I'm trying to explain how label encoding works. If you have
okay, like,
categories, I say it usually does them based on alphabetic order. So for instance, let me show you an instance. Now if I want to do label encoding, let's say I give you some group A, B, C, D. Okay, no, let me not say A, B, C. Let's say B, G, C, like this. And then I said you should apply label encoding to it. Now the way label encoding works is, no, let me just give it a real, let me use something more. Let's say let me say class A, class B, class F, class Z,
Uh, Mr. Emmanuel, you have a background music.
class Y.
okay, sorry,
Subtracting, sir.
sorry. So,
Okay. So let's say you have class A, class B, class F, class Z, class Y. Let's assume these are the different categories you have. And then I said label encode them. Now the way label encoding works is it will check all of them has class. So it will jump from that class. It will come to their letters A, B, F, Z, Y. So if it want to work, if it wants to label encode them. Now among A, B, F, Z, Y, which one comes first? This it will assign it label 0. B is going to assign it label 1. After A, B, F comes next in alphabetic order. So it will assign this one label 3. Y comes next. It will assign Y label 4. And then before it comes to Z, and then assign Z label 5. So that is how label encoding work. So it usually use alphabet to categorize them. So that is why I said in our case here we have just two categories, good and bad. So in order for it to label encode, it's going to start from letter B before it comes to letter G. You get, because letter B in alphabetic order comes first before letter G. So that is how label encoding works. So I don't know whether I've answered your question clearly and everyone is clear on that. Is there any other question? I think there's no question. All right, so let's proceed. Okay, Mr. Darwin, your question, sir. I thought Darwin raised his hand. Okay, I think he. Okay.
Yeah, say out of a case where there are two the same spelling in a column.
Even if they have the same spelling, there must be a letter that differentiate them. If they are not identical, for instance, let's say, let me give an instance. Let me give you an instance. For instance, let's say we have bad, like this bar, and then maybe we have bed. Let me assume,
Yes.
it's an assumption they are the same. They are in the same category. Definitely, bad will be given index 0 before bed will be given index 1. Why? Because after letter BB, it will go to the next letter. If the first two letters are the same, it will go to the next one. You understand? So if you check, it
Yeah.
comes before E. So that one that has A will be given 0. Then that one that has E will be given the next one.
Okay.
You understand? So there is no how. Except if they are identical. So except if both of them are bad. So, and if they are bad, since this one has been given 0, this one too will be 0 because they are the same.
Okay. Yes. Yes.
That is how the label encoding works. So I believe
All
it's
right.
clear, ba? All right. Okay. So please, whenever you have a data set that has categorical data and the data are not numeric, please ensure you always transform them using label encoding. Although there are other techniques of encoding, we have one hot encoding, we have label encoding, but label encoding is the commonly used one and is the one I mostly use. Although they are almost the same, but just that one hot encoding will create two different columns for you. For instance, let me show us an example. Let me rechange my data set. I want to change the data set to have those column back. Okay, now you see I've changed it back to goodbye size. So let me show you how that one hot encoding works. So that one hot encoding, you can also import it from these the same library. So if you are trying to import two or more things from the same libraries, you just separate them with comma. That is how you import another thing from the same library. So sorry. So now I've imported one hot encoder. So let's apply it to the data set. So let me just change this label encoder and then change the name to one hot encoder like this and then run it. Okay, sorry, I didn't run this. Okay. Coming. I think there's a change. They did an update on the. Okay, I think they did an update on the label encoder. I will need to check that first before I'll be able to get the right format for it. Because some of these libraries at times when they do an update, the formal way of how you write a code it will change. So unless you check the documentation, and I haven't checked that because I don't usually use that one hot encoding most of the times. This label encoder will solve your problem. So it's the same thing they will do, just that one will create more than one column. So all the good, it will put them in one column. All the bad, it will put them in another column. And it's not even usually good for your work whenever you're doing your analysis. So please prioritize usage of this label encoder. So that is how label encoding works. Now, the next thing that I did down here is if you check all these heights, they are floating number, and then this gender, they are decimal numbers. Floating decimal, they refer to the same thing. This shoe size too, but this gender specifically, their category, they are supposed to be 0, 1, 2. They are not supposed to be floating number. So I did a transformation to convert them to integer because they are supposed to be integer. Since their gender, 1 stands for male, 2 stands for female. So I don't want it to be floating number. Now, someone might ask, why does this column has 1 and 2 instead of 0 and 1? The person that created this data set, that was how he did his own label encoding. Although formally the data set has 3 attributes. Remember, that day we are the one that removed 1 that has 0. So that is why we have only 1 and 2. So that's to say in the initial data set there are 3, 0, 1, 2. So it was because we removed 0, that's how we have 1 and 2 left. So I want to change these floating numbers. Now height too, since it's in centimeter, there's no need for decimal number. Since it's in centimeter, we can make it to be a whole number. Gender, I ideally it's supposed to be a whole number since it's a category. And then these shoe size also, they are just 40, 41, 42. There's no 40.1, 40. So we need to convert it to integer too. So how do we do that? Any column that you want to convert, remember I told you if you want to change a column, if a column is already existing and you want to change it, all you just need to do is just to write the name of that column, and then you put equal to whatever you write after the equal to, we go and replace the old column. So I said this my data column sex number, I want it in the data set. This sex number, sorry, a minute, just give me 1 minute please, just give me a minute. All right, sorry. So as I was saying, I said whenever you have a column that you want to replace it, you want to change its format, all you need to do is to write the name of the column. Whatever you create as the variable, it will go and replace the previous one in the data set. So I said this my column that I write here, I want it to change it to integer. How will you say that? To say that, you say dot as type. That is, I want you to change your type. That is your data type. I want your data type to become integer. So to change any data type to integer, you just put dot as type. If you want to change it to float, you put float here. If you want to change it to string, you put str. So, but since it's already a float and then want to change it to integer, we put int, then you run. So the moment you run now, if I should output the data set, you see that that sex number has changed. It's no longer having a decimal point. You can see formerly it was having 1.0, 2.0. You can see now it has only 2, 2, 2, 2, 1, 1, 1. So that is how you change. So that is how you convert a column from one data type to another. So what I did here was I applied it on, I did for sex number, I did for shoe size, I did for height. It's the same thing I did. So, but it was the three of them. I transformed them. So I transformed them to my numeric values, to my integer value, sorry. So after transforming them, I run the data set now. You see that all of them have normal numbers. The only column that I allow you to have floating number is this size per height because it's a division. This is division, is the only person that I left as that. So that is how you can change one column from one data type to another. The next thing I did here was how to change the name of a column. Okay, Emmanuel, you can ask. I think any moment soon our meeting will be ending. So in case it ends, we'll enter the second link. So you can ask your question.
Okay, please, that place you actually changed it, that you changed this thing,
Data type.
this place.
Yeah.
So my question here now is, can you still write this code in form of data equal to sex number? No, data dot sex number equal to this aster type dot aster type open bracket int then dot the data like the thing the equation to change again. I don't know if you understand my question, right?
Maybe something like this, right?
Yeah, data
So
like data.
It will work.
It will still work.
Yes. Look at it. I just ran it now, and it didn't raise any error. So it means
Okay.
Yeah.
Okay.
Remember, I told you can represent your data either like this or like this. So whichever way it will work.
Okay.
All right. So I believe today we've learned how to label encode. We've learned how to do feature engineering. We've learned how to label encode, and we've also learned how to transform data type from one data type to another. All right. I think that's just the question you have, right? Or you have another one?
Yes. No,
Okay.
no, that is not the question.
All right. So the next thing now we'll be looking at is how to change the column names. Now, if you check this height, this sex, no, it doesn't make sense. This shoe size is long, size per height, they are long, goodbye size. You can change the names. You can change it. So how do you change it? Now, to change it, you create a dictionary. You create a dictionary having a key and a value. The key should be the old name of the column, while the value should be the new name of the column. So forget about this format that I did. It's the same thing that we've been doing. So let me just return it to normal so you won't get confused. Uh-huh. So the reason why I break it is because I know if I should write everything in one line, it would be long like this. So that was why I broke it. So another way you can break something to another line is just put slash here. Uh-huh. So now this is my key. The former name was height. So look at it. And then I said I want it to have a new name, HT. So anytime I want to talk about height, I'll just put HT instead of me calling height. Sex, no, I want it to become gender. Shoe size, I want it to become size. Size per height, I want it to be size HT. Then good, bad size, I want its new name to be size status. So after doing that, you pass it to a variable. Remember, it's a dictionary I created, so it must have a name. And the name of my variable is new column names. New column names. Now, how do you apply it to the data set? To apply it to the data set, you call the name of your data set. And then you said, on this data set, I want my data set to be renamed. So how will you write that? You say data.rename. Data.remain means I want to change the names to these new names. And then data.rename, open bracket, the rename is a function. It's a function. So immediately you write rename, it will have open and close like this. So you say, I want to rename my columns. You specify what you want to rename. Columns should be equal to the names that I gave here. These new column names. So that should be the new name of my columns. And then you run. Remember, new column names is a variable, a dictionary. So the moment we run it, it will change. So now let's print our data set and see. You see that your data set has new column names, different from the old one. You can see HT, gender, size, size HT, size status. So this just like I said the other day, I said in Python, there are some tools that we use to perform data visualization. And then I said that data visualization has to do with you representing your data given to you in pictorial format. That is what we call data visualization. So whenever you transform data that you have, columns that are in your data, you represent them using pictures. So the moment you use pictures to represent them, that is what we call data visualization. And I said in Python, we specifically use three key, although those are not the only libraries that we use. There are more than, but the commonly used libraries for data visualization are three. And I said they are Seaborn. The libraries are Seaborn, Matplotlib, and Plotly. So those are the three libraries that we use to perform data visualization. Now, it doesn't mean you must use all of them together. You can use just one to perform your visualization, although there are some of the libraries that they cannot do some things. For instance, Seaborn, you cannot use Seaborn to do a visualization of pie chart directly. So it usually gives an issue. So it has limitation in that aspect. Even Matplotlib at times, if you want to use it to plot pie chart, at times it will give you an issue. So that is where Plotly, like me specifically, I usually use Plotly whenever I want to do any visualization, I usually use Plotly. I don't focus on using any other um, visualization tool. I usually use Plotly. So the three visualization tool we'll be learning today is how to use Matplotlib, Seaborn, and then Plotly. For every plot that I chose, I did a visualization using those three different types of those three plots that we can use. Then I showed us the visualization. So the first thing you need to do is to import the libraries the same way we've been importing. However, I told us Google Colab usually have majority of all these machine learning based libraries installed in it. However, it doesn't have Plotly. Plotly is not a machine learning automated library, so you need to manually install it. So before we start, I will need to install. This is how you install it. You say the exclamation mark pip install Plotly. So since me, I've already installed it in my environment. That is why you saw it's showing this. So how will you use them? To use them, you will need to import them one after the other. Now, for you to use Matplotlib, you will not say import Matplotlib, then maybe as something. No, that's not how it works. In order for you to use Matplotlib, the aspect of Matplotlib you focus your attention on is called PyPlot. It is called PyPlot. So in order for you, that PyPlot is what you are specifically concerned with. So in order for you to use that PyPlot, you will need to import it. You will need to import it from Matplotlib. So for you to import it, you will say from matplotlib import matplotlib.pyplot, and then you give it a short form that you can use to represent it as we've been doing earlier. So the commonly used short form to represent matplotlib.pyplot is what we call PLT. So that is the commonly used short form that is used to represent matplotlib.pyplot. So you need to first of all import matplotlib.pyplot as PLT. So that's the first one. The second one is we import our Seaborn. So to import Seaborn, that one is straightforward. We are not importing any other thing different. So you just say import Seaborn as SNS. So that is how you import that. So after importing that, the last thing you import is Plotly. So Plotly, just like Matplotlib, Plotly also have a specific thing that you have to import and make use of. So and that thing is called Express. This one, Matplotlib, you import PyPlot, while Plotly you import Express. So you have to say import Plotly.express as PLT. There are other things that they have. However, to perform majority of your visualization, these are the libraries that you use. These are the ones that you always make use of. So you first of all import the three of them. You import myplotlib.pyplot as PLT, import Seaborn. Seaborn, I give it a name, SNS, that's the commonly used name, and then import plotly.express as. So we've done our libraries importation. So whenever, even you, if you are doing this, is the exact code you have to write if you are trying to import them. So anytime I'm importing something, whenever I give you a work, if you want to import, is the exact way I wrote it that you write, not you forming a new name. They don't have a new name. It's that exact way I wrote you have to write to. So the first plot we'll be looking at is the bar plot. Now, what is bar plot? Bar plot has to do with representation of your data using bars. Is what we call bar plot. So let me let's start with this line first. Now, the first visualization we did is a visualization using Matplotlib. So in order for you to do that importation, Matplotlib, remember we call it PLT. To plot bar plot or bar chart, Matplotlib has a function called bar. Now, most of the times that is how. Let's do it like this. Let me print dir of plt. Okay, I didn't run this one. Now, at times you can check all the types of plots that you can do using this thing that I just. You can see we have arrow plots, we have cycle plots, what. All these are functions that you can call from that PLT. You can plot even 3D plots with this matplotlib. All these like this, all these box plots, all these are names of plots that you can do. Although some are not plots actually, but majority of them they are plots. So how do you do that? So just like let me just rewrite everything. PLT dot. This is a bar plot. You say PLT dot bar. If it's a scatter plot, you say PLT dot scatter. If it is a line plot that is using line, you say PLT dot line. So that is how PLT allows you to output something. It's you just call the beginning of the name. So since it's a bar plot you are trying to do, say PLT dot bar, and then in your bracket now you pass it x and y axis of what you want to plot. The x axis, that is what you want to be on the horizontal axis, what you want to be on the vertical axis. Now normally horizontal axis is what we call x plot, and then vertical axis is what we call y plot. So in this my plot, what I want to do is I want my x-axis be the gender of people. That is the male, females, the gender. So how do you pass that? You will write the name of the data set and then the name of the column. This is your x-axis. And then you separate it with comma. Or for good practice, you can say x equal to, then you write the name of the column, and then you say y equal to, then you also write. I did a visualization of height against gender. That was what I did here. It's a visualization of height against my gender. Okay, sorry. Yeah, the y column in matplotlib, that y column, it usually sees it as height. It doesn't call it y column. You know, in your normal bar chart, you say x column, y column. But in matplotlib sees the x column as x column, but the y column, it usually call it height. That is why you see when I ran it, you say bar Mrs. Y require positional argument height. Now, not this height, the name of height in our data set, the y column of the data itself. That is what for the visualization, that is what it calls height. Run it now, you can see this is the visualization. So this is the gender. Now if you check, this center number is the actual number, and then you can see the center number is on 1, the center number is on 2. Then this side is used to represent the it. Although all of them do their calculation differently, each of the plots. However, this one I think it usually sums some number, like it's the average. This is the average, by this one the summation of the all divided, it will divide, to do some division and then bring them out. But whenever you want to do a plot, a bar plot using matplotlib, this is how you do it. So now if you check in the line me I put here, the first line here I specified something called plt.figure. Now this plt.figure, we usually use it to change the size of your plot. Maybe for instance you did a visualization and you notice that the size of your visualization is too small, you can change it. Now how do you change it? In order for you to change it, plt has a function called figure that allows you to change the size. plt.figure. So how do you change it? Inside the bracket, you say fig size. Fig size, Z-I-Z equal to. Then you specify the height and the weight. You specify the weight, sorry. The same way in the bar plot, I say x, comma y. Here you specify weight, comma, then height. So let's say the weight, I want it to be 15, and then maybe the height, I want it to be 6. If I should run it now, you see there will be a change in the look of this plot we are trying to plot. Now can you see? Can you see this shape is different from the one we have down here. They are not the same. You can see this one is longer. So that is how you change. Let me change it again. Let me change it maybe to 7. That's it. It changed. So this figure, you can use it to change the size of your plot. Now this PLT dot figure, you can apply it to whether it's Seaborn or whether it's Matplotlib you are working with. You can do this PLT dot figure and then you change the figure size. You can do that. So this is how you change figure size. Then if you want to plot bar plot, this is how you plot it. After that, you can give your x, your y axis, and then your plot a name. So in order for you to do that, if you want to give the entire plot a name, you say plt dot title. I can say bar plot using matplotlib. Let's run it. You see it has a title now. I'm taking my time to explain this first one because in subsequent one I'll increase my speed. You can see this is the name. Bar plot using matplotlib. So that is how it gives itself a label. Now the next, to give your y column a name, you say plt.y label. plt.y label. Then if you want to give x column, you say plt.x label. And then in bracket you write the name. Now what is our y label? Our y label, remember I told you, is this one that we call this height. And remember it represents the height of the data. So you can say y label should be height, then plt.x label. Our plt.x label is our gender, so we'll call it gender, and then we run. Now you see that it, for them, they will have a name now. So you can see our x column has a name, our x column has a name, our y column has a name, and our bar plot has a header. So this is how you create a plot using Matplotlib for bar chart. This is how you create a bar chart. Now, how do you create? It's the same thing here. It's the same thing here. But the reason why you see this plt.show is because we are using Google environment. That is why Google Colab. That is why I didn't write this plt.show. But if you're using normal, another different editor, you put this plt.show, your visualization will not be outputted. It will not show. So this plt.show that you see at the end, it helps. It's like saying print the visualization that I did, like show it to somebody. That is what plt.show stands for. Whether you put plt.show or you don't put, as long as it's with matplot and with Google Colab you are working with, it will run. So I'll be skipping some things if I'm explaining now, like this plt.title, plt.x label, plt.y label, plt.show. I won't talk about them because by now I believe you've understood what those ones means. plt.title, I say it will give the name of the plot. plt.x label will give the name for the x-axis. plt.y label will give the name for the y-axis. Then this figure too, you can use it to change the size of the figure. So let me just maybe 15. So now, how do you use Seaborn to create a bar plot? So Seaborn is slightly different from Matplotlib. So in Matplotlib, we say plt.bar, right? Why? Because Matplotlib, we imported it as plt. Now I want to use Seaborn. Seaborn, we imported it as SNS. So to do it, you say SNS. Now Seaborn does not see bar plot as bar. It sees it as bar plot. Matplotlib sees it as bar. Seaborn sees it as bar plot. So this one, if you are dealing with Seaborn, you must write the bar plot complete. So you open your bracket. Now, this one is slightly different from the other one. In Matplotlib, you will write the name of the data set before the column. But in Seaborn, it gives you that flexibility. You just say x equal to, then you write the name of the column. What is the name of our x column that we use? Because it's the same data I want us to be using and doing everything. The name of our x column is gender. So you just write the name of the column, gender, comma, your y column, the name also. What is the name? Height, but it's HT. Remember, in the data set is HT. Then after you've done that, you will now tell it data equal to, then you will write the name of your data set. If your data set is DF, you write DF. If your data set is data, like in our case, you write data. If your data set is another different name, maybe data 2, you write data 2. So, but this one is to allow you to write the x, the y, and then after that you tell it the data. Or this data you can write it at the beginning before the x and the y. But remember, the moment you write them, separate them with comma. So let's run it now. You see its own visualization. This is its own visualization. So you can see its own is slightly different from this one. So I told you their calculations. It's the same plot they will do, but their calculations are slightly different. Because you can see this one has some values separate. This small line that you see up is a representation of some values too. But this one doesn't have any line. So this one like calculate and then stop somewhere. But this one calculate, stop somewhere, and then use line to represent a continuation in places. So that is the difference between the plot of bar plot and that of Seaborn. You can see that both of them they plot their data differently. They plot their data differently. Then the last one is how to plot using um Plotly. So how do you plot using Plotly? Now for you to plot using Plotly, I said Plotly when we imported Plotly.express as px. So just like when we're doing just like when we're doing what's it called? Just like when we're doing Matplotlib, we gave it a name which we call SNX. When we're doing Seaborn, we gave it a name. When we're doing Plotly, we gave it a name PLT. When we're doing Seaborn, we gave it a name SNX. Now, when you are doing Matplotlib, if you are doing Plotly, Plotly now, Matplotlib and Plotly, they are different. When you are doing Plotly, this one gives you more flexibility. And look at something. Let me show you something. Let me put when I put my mouse here, did you see anything happen? No, nothing happened. When I put my mouse here, nothing happened. Now look at that of Plotly. Can you see something is happening? So this one gives you modern look, a visualization that has a modern look. Like it allows you to animate your graph. It allows you to animate as you are hovering your graph. You'll be seeing like a presentation of any point. You can see the height is changing as I'm putting the height is changing. Like collect is stacking all the height. The way this one works is going to stack all the height of all the genders that you have in the data set. That is how this one works. So how does it do its plot? So similar way to matplotlib, you say px.bar. The same way matplotlib sees it, it calls it bar. Seaborn is the only one that calls it bar plot. This one too calls it bar. But inside, the way you pass your data inside is now similar to the way you pass your data to Seaborn. Because this one allows you to specify your data, but you will not say data equal to before the name of the data. You can just pass the name of the data direct. That is how Plotly allows you. So you just write the name of the data. That is your data set. You just write the name direct, comma, or you can put it at the end. Remember, I told you the position doesn't matter. You can start with x-axis, y-axis before data name, or you can start with the name of the data, then x-axis, y-axis. So you can see after that, the name of our x-axis, we put gender, the name of our y-axis, we put, and then this one allows you to specify your title inside your Plotly the sequence of writing your plot. It allows you to specify the title and then it automatically knows the height and the gender. You don't need to. You see, like these ones, when we printed them without putting plt.x label, plt.y label, it has to manually go and put it. But this one knows. The moment you put and run, you see, it brought them out for us. It brought them out. So that is how Seaborn, Matplotlib, and Plotly perform visualization. So I don't know if there's any question on what I've done so far. Maybe you need clarity. I believe my explanations are clear, right?
Yes, yes, it's clear.
All
It's
right.
clear.
So let's proceed. So this is how you can plot your bar plot. So now in the other graphs now will be a little bit fast because it's just the name will change, but it's the same thing. It's just the name will change. So if you are trying to do a scatter plot, it's the same thing. A scatter plot is a plot that has dot 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 dot. That's what we call scatter plot. So in order for you to do scatter plot, you can do So now look at scatter plot. I did a scatter plot. This scatter plot, I did a scatter plot for height. I just changed the data. I did gender and height, right? Now here I decided to do a scatter plot for gender and shoes, height and shoe size. Height and shoe size. So I started, if you check the other one, I started the visualization first before I passed the title, the X label, the Y label. You can start with anyone. The important thing is make sure you write them. So, but this one you can see I started with them first, and then this is where I did the real visualization. So, formally we say if you are doing bar plot, say PLT dot bar, right? Now, since it's scatter plot, we'll write what? PLT dot scatter. So, what is scatter plot? Scatter plot is a type of plot that use point to output items. Now, what is the interpretation of this scatter plot? Now, the interpretation of this scatter plot. Now, if you look at we said our height should be on the x-axis and then our shoe size should be on the y-axis. That is how we say we want to plot the scatter plot. Now, what is the interpretation? The interpretation here is, if you check the height, the concentration of all these plots. If you look at this one here at the beginning, there's one here at this point, and then if you check the concentration is between these two, 150 to 200. So what is trying to tell you is in our data set, majority of height, people's height range from 150 to 200. That is the interpretation. And then if you check the shoe size on this side, if you check majority of shoe size, check it's above zero, it's not zero. If it's downward very well, it means it's at zero. So you can see it's a little bit above. So let me assume somewhere like from 10 like that, somewhere like from 10 here. And then if you check, majority of the concentration is within 40, range of 40. Some are above 40, but majority are not up to 50. If I should draw a straight line, you see majority are not up to 50. That's the interpretation of this scatter plot. A lot of our heights are within the range of 150 to 50, while our shoe size, a lot are within the range of 10 to maybe at most 50. But majority of shoe size in our data set are within the range of 40. So that's the interpretation of this scatter plot. So now, but if you look at, there are some shoe size that are far above, like this shoe size is around 90 and the height of the person is around 350. This person is a giant. Now it could be that is a mistake because during data there are mistakes. That is why I skipped a point. There was a point I was supposed to teach you earlier. I skipped it. I said we call it scaling data. You scale your data. There's what we call data scaling because if you didn't scale data, when you are building machine learning model, if you didn't scale data, there's what we call overfitting. When we come to machine learning properly, I'll still explain what overfitting is. Overfitting means when your data is performing well on some data, but it's not performing well on some data. And one of the reasons that can cause overfitting is presence of outliers. Now, what is outlier? Outlier is a point that is far from the remaining points in your data set. Example, all these data, they are close to each other, right? This guy is far from them. This is an outlier because it is not within the normal range. This guy is also another outlier. It is not within the normal range. Comparing this guy with these ones, this one is also an outlier, but this outlier is closer to reality than this outlier and this outlier. So whenever you hear me make reference to outlier, what I'm trying to say is outlier, what I'm referring to is any point that is far from other points. That is what we call outlier. So whenever you are trying to build a machine learning model and you build a data on data that has outlier, at times it will cause a problem, but not all the time. So it is good for you to build your machine learning model with outliers and then build it without outlier and then you compare performance to see which one is performing better. That is how it works. So these guys have interpreted what this scatter plot means. So, but we see that we have an outlier here. Now, when you are just looking at the data set with your eyes, you can't tell. From mere looking at this data set, you can't tell whether this height is an outlier. You can't tell. Or your shoe size is an outlier. You can never tell with your eye. That is where visualization is very important. But now that we did visualization, we were able to know that we have some outliers in our data set. It is left for us. If we want to remove it, we remove it. If it's left for us, if we want to leave it, we leave it. But remember, I told you, don't just feel like removing outlier, except if you are being told remove it, you must remove it. If you are not being told, work with it. And then after maybe building your machine learning model, you come back, remove it. After removing it, you compare. Okay, when I removed it, did my performance increase? That is, was my machine learning model doing better? Maybe when the outlier was there, the machine learning model has accuracy 35%. Then when you remove outlier, it has accuracy 97%. You will see that when you remove from these two comparisons, you will know that the one that has no outlier performed better. It means that outlier was hindering the machine learning model. But there are some situations that when you remove outlier, you see that the machine learning model started performing poorly. In those kind of situations, what it's trying to tell you is that that outlier is not a mistake; it is an important data. That is what it's trying to tell. Because now, from mere looking, I told you this person is a giant. That's statement one. And then statement two, I said it could be there was a mistake during the data collection. It could be that true, when this person was collecting this data, he met a giant and he got his shoe size as 90. You can't tell. You can't tell. We know it's practically almost impossible, but you can't tell. So that is why in machine learning model, we don't assume. We have to do it first. Apply it and see, did it work? Yes. If it works, fine. If it doesn't work, before you remove. So don't just assume and then use your normal knowledge to remove. No, it doesn't work that way. So our scatter plot was able to show that outlier is present in our data set. Outlier in height and also outlier in shoe size. Because there's a point here that has height about 90 and height above 350 and shoe size above 90. So it's an outlier. And then we have one again that the height is almost on zero, which is practically impossible. Even a dwarf is more than zero in terms of height. So, but the person's shoe size is close to 40. Your height is completely almost zero and your shoe size close to 40. It's an indication that there's an error with this data. So that is how it works. So this is how Matplotlib performs scatter plot. So the same thing applies to Seaborn. The only difference is Seaborn will say SNS.scatter plot. I told you anything that has to do with Seaborn. Seaborn always add plot at the end. So that's what differentiates them. So normal way, the way we did earlier, you give it the X, you give it the Y, you give it the data. Now there was something I introduced here called hue. Let me remove the hue first. Let's run it without the hue. Now, what is hue in Seaborn? Hue in Seaborn, now you can see the visualization is almost the same with the one we did earlier, it's almost the same. But what is hue? Now, Matplotlib does not allow you to put hue, though it allows you to do what we call legend. But if you want to do legend, you have to do two separate visualizations completely. But Seaborn gives you flexibility, it allows you to do hue. Now, what is hue? Hue is used to separate data points. For instance, now if you check in this my data set, I say hue equal to gender. Now, if you remember, we have two gender in our data set. Let me see why 0 0 and error. Okay, I didn't put comma here, sorry. Now, if you remember, we have two gender in our data set. Now, what is the essence of this hue in this data set? Now, if you check, there's something that came out here, gender 1. I remember we say 1 stands for male and then 2 stands for female. Now, ideally, if it's letter based, 1 is supposed to stand for female, 2 is supposed to stand for male, right? Now, but the person that prepared the data, the reason why I'm telling you 1 stands for male, 2 stands for female, because in the original data set, because I've used this data set to build an application, from the data set, I was able to notice that the person interchanged it. He didn't use normal label encoding. I think he manually encoded it. And then the documentation, I think I saw the documentation of the data set too. He specified that he used 1 to represent male and then 2 to represent female. Because if you didn't use label encoding, you can decide which one. But whenever you decide, make sure you interpret it to somebody that will use the data. If not, if the person is just assuming, he will believe you use label encoding, and he knows ideally 1 is supposed to stand for female because F comes before M. So that's how it's supposed to work. But the person interchanged this one. 1 stands for male, 2 stands for female. So now you look at that there's a separation in our data set. So hue helps you to provide a separation. This yellow one here stands for the males, and then this dark one stands for the female. Now from here, what is the interpretation? Now the interpretation is, if you notice, majority of men have shoe size that are above those of female. Because if you check, almost all these male, their shoe size are almost above 40. They are moving towards 50. From 41, 42, like that. Then the female, their own, they are they are around 40 downwards. So that is what the hue helps you to understand. It will differentiate data. It will show this data belongs to this category of people. This data belongs to this category of people. So that is how hue works. So Seaborn allows you to put hue so that you can separate your data. You distinguish them into different categories. So that is how hue works. So the same thing too. This Seaborn, sorry, not Seaborn, Plotly. Plotly also allows you to pass a hue too. But his own, he didn't call it hue. It usually calls it color. It calls it color, not hue. So the same way, if you check Matplotlib and Seaborn, they usually give their charts or their plots the same name. If Matplotlib say scatter, Plotly too will say scatter. It's only Seaborn that will say scatter plot. If that one say bar, the other one will say bar. It's only Seaborn that will say bar plot. So that's just the difference between them. You can see it say px dot scatter. I pass the data, I pass the height, I pass the y, and then color. That is the hue. I told you Plotly calls it color. It is Seaborn that calls it hue. So if you are doing a Plotly plot, please use color for separation, not hue. Hue only works for Seaborn. So let's run it. You can see this is on separation, and you can see this one has some animation. These blue ones, now if you can check, this is his own. This one gives us a scale here, but this one gives us a scale by the side. He said these ones that are moving towards yellow are for two. That is who do I say are being represented by two? Females. Females are the ones that have two. Then he said the ones that are blue stands for one. That is what it means. So anybody that has a blue color is representing male. Then anybody that has yellow color is representing female, because we have only one and two in our data set. So forget about this 1.8, 1.8. These ones are not relevant. It's just trying to show you a color scale. The focus should be on those categories that are in your data set. So you can check the visualization are almost the same. But you can see this one has like a more of an animation, but the interpretation are all the same. So that is how Plotly does his own visualization. Then the next one is histogram. So if it's histogram is being represented as hist. So if you are doing histogram allows you to plot. You can do a visualization for just one. Most of the time, histogram, you are to plot just one column. Histogram does not accept, let me see, it doesn't accept X and Y. Although let me try it, because most times I usually do a visualization for just one. Let's run it and see. I know it doesn't accept. You can see it raises an error. Okay, sorry, I've not finished. Now you can see it raised an error. It says multiple values for argument base. That is to say, you pass too much data. So histogram allows you to pass only one data. So that column that you want to do a histogram plot for is what you have to output. So I want to do a histogram plot for our shoe size. So this is the code. This is it here. Hist. So let's run it, and then let's see the histogram. Now this is the histogram. Now what is the interpretation of the histogram? The interpretation of this histogram is the concentration of our shoe size is mostly from within this range down to 50. You can see majority of the concentration is here. Majority of the concentration is here. So that is what histogram shows you. It shows you a place that has concentration very well there. Okay, I think we have those 15 minutes, so I have to hurry up. Let's round up and stop there. So that is how histogram works. Now, if you check in this histogram, there's what we call bin. Now, bin, let me show you something. If I should increase this bin, you see the plot becomes smaller. And you can see something happen. Now, what the bin stands for, it helps to divide your data points. Because you have plenty data points in our data set, it will divide them small, and then represent them in the graph. Now, it's trying, now from this bin, as I increase this bin, I'm trying to be specific. I want to get the exact place that has a higher concentration. Now, if you check this place that combines together, this one has higher concentration. It's trying to tell us that majority within the data set, majority of data sets, a majority of data point have shoe size closer to this 40, around this region like this. That is where the higher concentration of shoe size is. But when I put it as 10, it didn't give me clear interpretation of that. So the higher the shoe size, the higher the bin size, the clearer the information for you. You get the place that has more concentration. While the lower the bin size, it will give you like a wider scale, a wider representation of your concentration. Like now, when I increase it, then you can see I said from, let me say like from 20, I can call it maybe 20 to above 50, or 20 to 50 is the concentration of my shoe size. That's a generalized representation of the shoe size. I can do that for height to make, let's assume is our height. So I want to check. Okay, sorry, we change it to HT. I'm supposed to write HT with height. So you can see the same thing. So from this now, from just the little example and illustration I said earlier, you can understand this histogram. What this histogram is trying to tell is that majority of height is between 150 to 200. So let's increase our bin size to 100 and see. Now mind, it mustn't be 10 and 100. You can increase it to any number of your choice. You can test. So if you can check now, majority of the highest in terms of concentration are height in between 150 to 200. So the middle of 150 to 200 is I think 175. So that is the region that has the highest concentration. These two that are meshed together, these long ones, they are the middle. So 125 is like the highest. So 175 is the middle of 150 to 200 is the middle. So that is where majority of height concentration is in the data set. So let me return it to what is there formally. I just did those changes to show you how histogram to interpret how histogram works. So the same thing if you are in Seaborn. If you are in Seaborn, the same thing, just that is when you call it hist plot, and then his own here we say beans equal to 10. This one you don't say beans, you write bean width. Bean width, that is how you interpret them. Matplotlib you just write beans, but in Seaborn you must write bean width, not beans. It doesn't know that. So the moment we run it, you see almost similar. You can see almost similar thing, most similar thing. Just that I think this one has border radius. I think you can set the border color too. Let me check something. Does it have a border color? Okay, just leave that for now. Let's just leave that for now. I wanted to put in a color the same way this one has black color around, but let's just leave that for now. So that is how Seaborn represents its own too. You just change the name to histplot, then plotly too. His own is histogram. Now it's only here now that it has a different name from that of PLT. PLT calls it hist, but plotly calls it histogram. I think someone is raising his hand, right? Okay, someone wants to join. Okay, so PLT, that's Matplotlib, calls it hist. SNS, that's Seaborn, calls it histplot. Then Plotly calls it histogram. So this is the only place that is different. It calls it histogram. So the same way you pass your data, your X, and then his own too. Matplotlib calls it beans. Seaborn calls it bean weight. Then Plotly calls it n beans. So please always take note. So whenever I give you work to do, always refer to this one that I showed you. So the more you are using it, as you are practicing, you are using it, you become used to it, and you will know you will not carry the one of Seaborn and be using in Matplotlib like that. So histogram in Plotly, it calls it n beans. So if you want to change the number of beans, that's where you go and change. So let's run it and see the visualization. Now you can see they are all almost the same. They are all almost the same, just that this one I told you to add animation. So the interpretation is the same. So the next plot is called box plot. The next plot is a box plot. Okay, I think after box plot, then the last one pie chart. Now box plot. Box plot is a plot that you represent your data in boxes. Now we usually box plot is the plot that we usually use to check for outlier. Remember earlier I showed you how to check for outlier using scatter plot, right? But ideally the one that was specifically created for checking outlier is box plot. You can check outlier in every column. Like here, I did an outlier check in my size column. I want to check which shoe size is an outlier. So to do a box plot for it, you say plt dot box plot. I think even book should work. Okay. Box only accepts series data type, not a data frame. Okay, so box plot. So now box plot, matplotlib calls it box plot. So if you check, I did a box plot check for my shoe size. Now if you remember when we checked here in the data in the scatter plot, I told you the shoe size that is not normal here is around 90. Now if you check this box plot, you see that. Can you see the shoe size? Is here, is around 90. Now, what is the interpretation? The interpretation of this shoe size. Now, any zero that you see, or any black in Seaborn, you see them, they are black. Some you see them black, highly concentrated. Any place you see them, they are outlier. Now, what does this line and this box means? What it means is majority of the data sets are within this range from the starting of this place to the starting of this place. Now, what does this yellow line in the middle represent? It means the average shoe size. Whereas the concentration, the highly concentration of shoe size are above zero, but not up to 50. Any number that is up here, upwards, or maybe any number after this dash line, this downward, all of them, those ones, they are outliers. So your concentration of shoe size in this data set are this. So you can also do that for height. So since I've explained this for shoe size, let me use Seaborn to do for height. Let me use Seaborn to do for height. Now, but in Seaborn, you have to specify, like in Matplotlib, you don't specify whether you do it X or Y, it will plot it vertically for you like this. But in Seaborn, you have to specify. If you want it to plot it vertical, similar way this guy did, you have to write Y axis. Because if you didn't specify, it will take it to the X axis and then it will plot it horizontally. Let me show you. You see it will face this direction. You can see it's facing this direction, which is not what we want. We want it to face up and down the way this one is facing. So you have to specify, you tell it Y. I want your direction to be Y axis, and then you pass the data to it. So you see for the height. So what is the interpretation? The interpretation of this data set is we have some heights that are outliers, heights that are above 400, or heights that are below 150 or closer to 100, they are outliers. But where is the concentration of our height? Concentration of our height are between 150 to 200, with their middle being the average. So the average is around 175. So that is the interpretation of box plot. So just like I said, box plot is used to check for outliers in a data set. So let me change maybe this size. Let me increase it 15,7. Then let's run it. So you can see, so that is how box plots work. The same thing if you want to do with your PLT, with your Plotly, is the same thing. Plotly is zone, it calls it box. See, Matplotlib calls it box plot. Seaborn too calls it box plot. This is the only place that two of them align. They call something with the same name. Then PLT, the Plotly calls it a different name called box. So the same thing, you pass your data, you pass. Similar way here, you specify. You tell it, I want it to be Y axis. The same thing here too, you specify, I want it to be Y axis. And then I did for size. That's the same one I did for this guy here. Was what I did here. And then we run it. So you can see it. for the shoe size. You can see these are the outline. So if you check these Plotly plots, they are more fancy. So whenever you are doing a professional work, I will advise you always use Plotly. Or even if I should give you, except an assignment or any work, maybe machine learning work, and I say you should explore the data before you do analysis, always prioritize the usage of Plotly because it has a better look and appearance. Always use your Plotly, except if I specify, I say maybe use Seaborn or Matplotlib. But if I just say visualize, always use your Plotly. So this is how box plot can be visualized using Plotly. Then the last thing now we'll be looking at is pie chart. How do you plot pie charts? Now, to plot pie chart, you cannot use Seaborn to plot pie chart. Seaborn does not allow plotting of pie chart, but Matplotlib allows, but it is not flexible too. Matplotlib can only visualize data in as pie chart if you group them. If you group them, that's the only way it can visualize it for you. Now, the reason why I did this one, I left it on purpose because I want to show you guys something. Now, if you check, when I said, let's go back to the code, I said do a pie chart of shoe size. Now, for pie plot, this one doesn't have X and Y axis. It only accepts two things. If you are doing a pie chart, the data you want to use to divide, and then the label, that is the labels that should appear. You know, normally pie chart always have a label, maybe group A, group B, group C, and then you show their percentage. Yes, that's how it works. So the same thing. So this data is what will be used. This data size, that is the shoe sizes. I want you to use the shoe sizes to calculate, and then the labels should be my gender, that is A and B. So I'm expecting to have a pie plot that has only two division. One should stand for male, one should stand for female. However, you should use their shoe sizes to do the classification. But if you check, when I ran the code, this is what it's showing me. That's to tell you Matplotlib is faulty when it comes to grouping this kind of data. Why? Because it wants you to manually group the data for it to be able to interpret. So that is one limitation of Matplotlib that makes it not suitable for pie chart. In fact, Seaborn, that one automatically doesn't even allow. So that one is gone. You can't use it. So that is where Plotly is more flexible than them. So you can see Plotly, I just go to x.py, and then I said data, that is the name of my data set. And then values, this one you write, instead of say xy, you give it a value. Only in pie chart, please take note. If you want to plot a pie chart, it is not x and y you give him values, that is the values is to use to divide your cycle. And then the names, that is what should appear on the pie chart. That is what we call name. In Matplotlib, I said we call it labels. Here we call it names. So, and then you pass it a title. Now, if you run it, you see that this one will give you an exact plot that you don't need to calculate anything manually. Can you see? You can see that this one gives you a plot. You can see this is the plot for those that have one, that is females, and then this is trying to show you that male have more shoe size than the females in the data set. So that is how um, Matplotlib does its visualization, and that is how Plotly does its visualization too. So always prioritize the usage of Plotly to do majority of your visualizations. So this is what I have for you guys today. So I'll stop here and then give room for questions.